Greetings RUBE users, version 1.6 is out now, and this video is going to take a look at some of the new features that have been added. Once again, I'll do this thing where I list them up at the beginning of the video like this, and you can click through on the annotations to jump to those sections. The biggest feature that's been added in this excuse me, I have a bit of a cold, in this update is that samplers have been added, and this is a completely new item type, so it has a new script class and everything for it. And well, obviously I'm going to explain what samplers are, but in this video I'm not going to explain all the details of usage of samplers. I'm going to make another video later on, hopefully in the next 2 or 3 days, to explain that, because it's a big addition and it needs a proper tutorial video to explain all the details fully. So if you see something in this video about samplers that is not really explained, or I'm not really telling you how I'm doing something, don't worry too much. You'll be able to see a proper video on that later. The documentation is written, however, so in the meantime, before that other video is out, you can probably use the documentation, the built-in help that is, to figure out how to do things, I think, and I will point out where that documentation is when I get to this point as well. So once again, I will start from the simplest things first, and right, let's get started. Undo stack view. Let's see what that is. So if I make a new project, and the undo stack view is in a docking panel, and you can open it from here. There's no shortcut key at the moment. I don't think this will be such a commonly used docking panel, but we can add a shortcut key there if you want later on. I just don't want to use up all the available function keys too quickly, that's all. So what this does is, let's see if we add a body like this. We can see that as I start editing the scene, each of the actions that I'm doing, let's make a star like this, each of the actions I'm doing is listed up here, and I can click in here to jump back to previous situations that I had. So this is just a visual way to look at the undo stack, and it saves you from doing Control-Z multiple times to jump back a lot of steps. So if I go right back to the top, it's the empty file. It's a little bit slow if you're stepping through a long list of undos, just because of the way that RUBE processes undo and redo information. It does it by compiling text and running scripts and so on. So just when you click on here, just give it a second to catch up to you. This is something that's in a lot of other apps, so I don't think it really needs too much explaining. Okay, what's next? Convex hull, merge vertices, split lines. These are just a few useful scripts that have been added to the action menu. Convex hull, that should be pretty obvious. That works on fixtures and just runs like that, so as you might expect. Merging vertices, let's make this shape a little bit more interesting. Suppose you have two vertices like this that you could almost kind of just make them into one. Merging vertices will do exactly that. This is kind of similar to something that we've had already, which was I have to select two of these. We had weld already, which that changes the position of both of the vertices. And merge will actually delete one of them, so just to show the difference. Weld is handy for when you have a situation like this where you have things close and you want to just force them to be in the same place like that, but I don't want to delete them because they're in separate fixtures here. So that's what weld will do. And merge is similar, but it will actually delete one. The need for this is because if you use weld on two vertices in the same fixture, you get the problem that you can't have polygon decomposition doesn't know what to do when it gets that situation. So that's why we use merge instead, like that. Split lines. Okay, split. This is also kind of similar to something that we've had already. If I select these two vertices here, these are non-adjacent vertices, and we already had a thing called split fixture polygon. I've split this into two separate things here and given them the polygon and the line suffixes and brackets here. This is more intended for polygons and this one's more intended for lines. You can use them on any type of shape, but it probably won't get what you want. So for polygons we would split things like this. That will give us like that, two separate fixtures. For lines though, let me just make this a line. Splitting a line is, for example, if we take two vertices here, and this time we choose vertices that are adjacent, and we basically just clip out the segment in the middle there. So that is split fixture line, and now we have two fixtures again like this, and the fixtures remain on the original bodies that they started on, obviously, as you can see, like this. Okay, what's next? View position script functions. Alright, let's use this scene. View position script functions are, oh, here's an example, get view center. If I just run this script here and I just print the result of that, so if I just do print get view center, you'll see that that just prints out the center of the view as it currently is. So if I move the view a little bit and run that script again, it changes a little bit. And there's also get view height. If I run that, we just get the height of the screen in physics units. So if I zoom in, it gets smaller. And there are also the other side of this that is set, so you can set the view height and the view center as well. So this is just handy for things like, one thing that I've found it handy for so far is the script that we were just looking at here, which was a view bookmark. And this is set up to run with a key press hook event. So let me just set that up. So I'll put it onto key presses 1 and 2, like that, and also onto key press 2. So that means that when I press the key 1, the script will run. And depending on whether I have the control key down, it will either look at the current view center and write that to file, or if the control key is not down, it will read the file and then it will set the view center. So let me say, let's say I'll look at this bottom pile of rocks here and I'll do control 1, and then if I go away and I look at something else, now if I hit the 1 key, it will bring me back to that bookmark. And I could do that with this other pile of rocks here. So if I do control 2 over here, now I can switch between my two view bookmarks by hitting 1 and 2 like that. Keep in mind that you can also do this by having multiple views. So I could just go like, oops, that one, and so I could have two views to do this, but if you're using a small screen or you just want to keep everything in one view, it could be handy to do things with view bookmarks instead. Okay. Okay, negative scaling improvements and associated script functions. What do I mean by negative scaling? Negative scaling is when you have some bodies and you scale them and you restrict it to either the X or the Y axis and you bring them across to the other side of the cursor like that. So you could call it mirroring, I guess is probably what most people would more commonly call it, but technically it's a negative scale, so I'm just going to call it that. and this was never actually fully working properly until now in RUBE, and I'll use this here, which is an older version of RUBE. This is version 1.5.3, and I'll use this structure here, which is quite a complex one. We have a lot of joints with a lot of limits, and there's images on there and everything, and this is a really good example to show the problems that have occurred. Let me just make this a static body while I'm here. Okay, so the cursor goes here, and select all those bodies, duplicate, and scale them across there like that. Now we can see immediately some problems. Obviously the images have incorrect rotations. Now their positions and sizes and everything are correct, but the image rotation is wrong. We can also see that the fixtures, the vertex winding of the fixtures have been reversed. So instead of getting nice polygon decompositions like that, we're getting the triangulation instead. And you can fix that by reversing the vertex winding like this, but it's just a bit of a pain to have to do that afterwards. What else was the problem? Oh, joint limits for revolute joints were all out of whack after doing this, and it's a bit hard to show that properly here. So let's look at this in a player view, and I'll just turn off the body images. Okay, so if I run this, you can see we have a bit of a problem here. The original guy over here on the left is fine, he's looking good. Yep, yes, looking good. And this one is not looking good because the revolute joint limits are basically just incorrect, so we can do this with the arms as well. So he's not looking good. And the other problem was that the direction of the motor for this would be for wheel joints and revolute joints. It's clockwise in the original copy, and over here it's still clockwise. So it's not really a proper mirroring of it's not really a properly fully mirrored outcome. So basically, to make a long story short, in the current version of RUBE, that is the one that's just coming out, we can do all of those things with no problems at all. So if I flip this guy over here and play this in the run view, in the player view, we get a properly mirrored result. So all of those problems that I just described are no longer an issue. Hey, settle down, you guys. Okay, and now that that is done, we can also have some script functions to do that, and they are, let me just find them. It's global functions, body related. It's mainly to do with bodies, this one, but there are also the same functions for fixtures and so on. Okay, so now we have this function here. We can do scale an array of bodies and give it the X and Y scaling. So this opens up a possibility for scaling the entire world and flipping it, which hopefully the people that were kind of complaining about this a little bit, I think they were mostly JavaScript and Flash users for which the rendering context is vertically flipped. Those people they wanted to flip the context before they exported it automatically. So now that we have this function, you can do that, and we'll have a look in a minute about how you can actually do that automatically every time you export. Okay, new script hooks. So a script hook, as we just saw, is something that will cause a script to run automatically at certain times in the program. For example, just before, when I pressed the 1 key or the 2 key, I was running a script automatically. So we have a few more hooks added. After manipulations, and before and after export. A manipulation is either a translation or a scale or a rotation of an item or a group of items. So let's have a look at those. Sorry. Let's use this scene, and I'll put a body up here just so that we can move something around. And in the script hook setup, we can see down here we have some more events. So we have bodies manipulated, and also the same for fixtures, joints, vertices, images, and samplers. And what this means is that we can cause a script to run after we do a manipulation in the GUI. And I have a script here called print hook event info, which will just print out some information, and I'll put that onto bodies manipulated just so that we can see it. So when I manipulate bodies, the script will run. Oh, and we have to open the log view so we can see the output. Okay, so I'll just translate this body over here, and when I complete that translation, we'll see that the script runs, and it's just printing some information here. That's the name of the hook event. The type of manipulation was translate, and we can also get a list of the bodies that were translated. So if I do a rotation, this time we get a rotate, and scale gives us a scale, and so on. So you can use this to update things in your scene, and we'll have a look at an example of that right now. I was sort of thinking of putting this into RUBE at some point in the future, but there was a post in the forums, thank you Nautical Mile, who was discussing ways for making things more convenient when you have a lot of very similar objects like this. And in my video recently where I did a case study on constructing soft body wheels by using a bunch of joints like this to cause wheels to be softish, it was pointed out that it's kind of a pain in the butt to have to run the script again every time if you want to change the template or the prototype body. So if I wanted to change the fixtures to be like this or something, I would basically, with the method that I described, I would have to, the easiest way to do it would be basically just be able to delete all these ones and run the script again, which is kind of not very efficient way to do things. But what we can do now is, did I just skip over that? I think I skipped over this, didn't I? Alright, yeah I did. Basically what this lets us do, I'll just skip back to that for a second. What this lets us do is, when we have a script, you can get a list of the bodies in a scene by name, like this, body name. So whatever whatever bodies in the scene have that name will be returned to, and you can do something with them in script like that. I kind of messed up the order of things, didn't I? Let's go back to this scene. This is what I was going to demonstrate this on. Let's say that all of these bodies here are called rock, and we want to have a script that does select get bodies rock, like that. So if I run that script, I can select all the bodies in the scene that are called rock, which is those ones. So this, when you're writing scripts, is quite handy to be able to get a list of bodies to work with. What's not convenient about this is that you may want to call these bodies rock, but you might want to select a subset of them. So you might want to just say select the top ones, in which case selecting them by name is not going to help you. The The only way you could do that is by giving different names to the bodies at the top than at the bottom, and that's not really the ideal situation. But what we can do now is we can say, if we had a string property called let's just call it layer, and for the rocks at the top we'll say they're top, rocks at the bottom are bottom. So you could think of this as a tag. We're not changing the name, but we could give multiple tags by adding more properties here to things in the scene. Now in our script, instead of getting bodies by name, we can do get bodies by custom string, and the name of the custom property that we're interested in was layer, and let's say we want to match all bodies who have the custom property set to top. So when I run this script, now we can find things in the scene by that tag. It's not really a tag, but you could think of it as a tag. So for for people who don't do a lot of scripting, this is probably a who cares kind of a thing, but for people who do some scripting, this is hopefully going to be quite a handy feature. Right, now let me jump back to the the other thing I was looking at here with script hooks. So after manipulation, let's get rid of this now. Alright, so let's say I'm editing the rim of the wheel, and I have everything set up here with my joints and my bodies and everything, and then I want to change the shape of the fixtures around the outside. It's not very convenient to run the script again every time to regenerate all those bodies, but what I can do now is I'll take one of these bodies to be a template body, and I have to remember to get rid of those joints there because they get copied along with it. Now what I'm going to do is I'm going to edit this fixture, and I want all of my changes that happen to this fixture to be applied to all of the other fixtures around the outside. So I can do that by adding a custom property to fixtures, and I'm going to call this property template. Now this fixture in the middle here, this is going to be the template, so I don't set any property for template in here, but I do need to give it a name, and I'll call it boss because this is going to be the boss of all the other fixtures. And so all the other fixtures here, I'll select them, and we should have 36 of these, I think. 36, yep. And for all of those ones, I will say that their template is boss. Now I need a script to help me with this, of course, and if we go back to this print hook event info, this is what I was running before to see the this output here. So at the bottom of this script, actually it's kind of confusing to have it in this script, so let's just make another script. Make a new script, paste, and what happens here is we get a list of the fixtures that we manipulated, which is that one, and then we go through the scene and we try and find all other fixtures who have the name of this fixture set as their custom string property template, and then we do this set vertices thing where we just copy the vertices across from the template fixture. You could do other things, you could copy the radius of the shape and so on, but for this demonstration I'm just going to copy the vertices. Right, let's, where have we got this? Projects, RUBE installed. This should go into my folder here, and I'm going to call it UK fixtures from template. Yep. And I'll give this a nice name here as well. Fixtures from template, so that when I save this it gives me a nice name here. And so now this script here, I'm going to attach this to the fixtures manipulated event, like that, and I'll also put it onto the vertices manipulated event, so that when I change either fixtures or vertices, the script will be run. Okay. Now let's see what happens if I take this fixture and let's say I rotate it. You'll see that all of the follower fixtures have copied their vertices from that fixture. And when you undo this, just incidentally, we can see that these are two separate commands in the undo stack, so you can actually redo and undo these separately if you want to. Okay, so for vertices as well, if we change a vertex, we can see it changing in all of the other fixtures that are the followers. So as you can see, this makes things a lot easier when it comes to adjusting your follower fixtures after you've already created them. This is the most probably the most commonly will be the most common use of this feature, I think, in the future. But there are, because it's scripted, I mean, you could do all kinds of other things as well. Excuse me. Right. So, what else do we have in the way of script hooks? Okay, before and after export. So, let's have a look at another script I have here. And this script is called Flip World Vertically. So there's a couple of things going on here. First we put the cursor to 0, 0, and then we scale this A-B thing here as shortcut for get all bodies, like that. So we get everybody in the world, and then we flip it vertically. That's what the last parameter here is doing. And we're flipping it around the point 0, 0. And then we also set the gravity to be reversed as well. So let's run the script here. And as you can see, that flips the world. If we run that, we should see that gravity is also flipped. So I think the JavaScript and Flash users would be wanting to export their world in this state, and then they'd want to flip it back again after they've exported to continue editing. So we can take this script here and we can attach that to the other new events that we have. Before export, we want to flip the world, and then after export we want to flip the world again. So 2 flips is going to return everything back to normal. I'm not going to demonstrate exporting this, but you can just believe me, it works. For large scenes, it could be for large scenes it could be a little bit slow, but it should still work. Right, step bodies in editor view. This is something that some people have been wanting. What can we do here? Right, let's do like this. I'll make a square fixture and I'll just make it a little bit odd shaped. And then we'll make a bunch of those. Like this. So in the player view they'll fall down like that. Okay, and actually let's make them so they'll end up in a pile like this. That's how they'll end up settled. And quite often you want to have things settled already before you start running the world. So what you can do here is select all of the bodies that you want to step the simulation for, and you can choose from the action menu you can step selected bodies or all bodies. I'm just going to step the selected bodies at the moment, and then we can choose the number of steps. At 60 frames per second, 60 steps will be 1 second. I want to step everything until it's completely settled. So 600 seconds is 600 steps is 10 seconds. Let's give it 20 seconds just to be sure that it's completely settled. So that should be the completely settled state. Actually, it doesn't look like that's settled, does it? Let's see if it works. So if I reload and run, yeah, you can see that basically nothing's moving here. So I guess that is actually settled there. It must be just just on the edge. Okay, so that's stepping selected bodies. So just keep in mind that you need to, if you use this option here for stepping just a subset of bodies, you need to have, most cases you'll want to have the ground selected as well. This is undo and redoable, by the way. So if I undo that and I select just those bodies and run it for let's say 2 seconds, you'll see that they just fall through the ground because I didn't have that one selected. So just keep that in mind. Okay, samplers. Get rid of this and close that. Okay, samplers. So this is the main bulk of the 1.6 new features. But like I said, I'm not going to go over it in too much detail in this video. I'll just show you what they are and what you can do with them. So let's have a new scene, and in my new scene I will put a sampler over here. So you add them similar to adding other items, and we can select them and move and scale and rotate and so on, and you can see them as their own separate item type here, samplers like that. So they basically fit alongside images in a way they're quite similar to images in the way that you move them around and the way that they are rectangular areas of the screen. Now there's nothing in here. A sampler doesn't actually contain any content of its own. All it does is look at images in the scene, and let's get some images in here. Okay, let's use this image, and I'll just want my images to start with alpha of 1. Let's check. That's better. Alright. Put this one over here. Alright, so now we have an image. Now we can do some sampling. So samplers are able to do two main things. One is to take a sample of the image data that they see and write that out to a file, and the other main thing that they do is they can find edges in that image data and use those edges to create fixtures for your physics shapes. So first off, we'll just look at outputting image data, and to do that I need to set a file for the sampler to output to, and this is actually a good one, this folder, that one there, output. And once I've set a file to output to, then I can come down here, I can do write sampler output to file, and I'll just close this off here a little bit so we can see what the result is. So now we should be able to see the result. So hopefully you can see what's happening here. We're just taking a look through this rectangular area and we're dumping that to file. And the size of the file here is defaulting to, this is the default values, 256 by 256. We can make it a bit higher if we wanted to, say 512. And if I do this again, we'll see that now normal size. Hopefully we can fit this on the screen. Yeah. So this has given us a larger image. And if we move this sampler around and sample again, you can see that we are just taking that section like that. Now that's not too exciting in itself because we're just sort of cutting a piece out of an image. But what's useful about it is that we can do this in the same way for multiple images, all layered over the top of each other. Let's just make sure we get these in the right order. That one at the back, this one next, that one after it, and then the leaf on top. Right, now if I put my sampler over here to grab all of these images and output to file, we can see that we've sampled all of those images like that, and we can zoom in and do stuff like that. So that's the basics of outputting images to files. The other thing that you would do with samplers is to oh man, use them to find edges in images. And this one is a good example here, because this image, if I just look at the original image here, you can see that it is surrounded by empty pixels, or fully opaque, fully transparent pixels here. So this is a good one for finding alpha edges. And if we just make the sampler like this, and then we do edge refresh now, you can see now we've been given a green outline here which shows us the alpha edges around the outside of this image. And then we can find a path around these green sections, and we can use that path to set up vertices for physics shapes. Let me just put this back like that. And we can do that manually, or we can do it automatically. I'll just show you the manual way first. We come into a special editing mode here, and I can put points around here manually, and you can see that, maybe a little bit hard to see, but there's blue lines following around here around the edges. So this is actually a pathfinding algorithm. It's not marching squares. Oh, that's not what I wanted. Oh, that's okay. And we can move those points around, so we can get something like this. And then we can adjust the number of points that we want to use for that path, like this. Or alternatively, we can adjust the minimum angle that we want between consecutive segments in the line. And when we have something that we're happy with, like say something like about that, then we can do create fixture from sampler. And the way we're using it at the moment, it needs to have a body selected to put the fixture onto. So if I just put a body here, yeah, fixture, whatever, and then do that. I have to select the body too. Select. Okay, create fixture from sampler. Now we can see here that we've created this lovely fixture just by tracing around the outside of that image with a few control points. For this particular example here, I think you might be better off just making a fixture in the normal way, because it's not a very complicated fixture. So the strength of this system of using samplers to do it really only comes into its own when you have a complicated shape. So just as an example of that, let's use this image, and we'll make instead of putting a sampler over this image manually, I can actually just use the image dimensions to create a sampler from the image like this. And in samplers mode, so now we can see we have a sampler that's placed itself around the outside of that image. It's actually a little bit bigger because we want to include the border of the image as well. So now I can, in my edit mode, I can place the oh sorry, I need to refresh the image edges. Now I can place my control points around here like this, and I can get this shape to be made pretty easily like that myself. That's not what I wanted. Let's see, put this one over here, like that, and then like that. So I'll cover the details of how you do this in my next video. So that's the manual way of doing things. What we could also do, let me just delete that sampler. We could also use a fully automatic one-step solution, which is this one here, create body and fixture from image. So in this case I just select an image and I do create body and fixture from image, and this will give us some values to use for those sliders that we had. I'll just click through those as they are, and it also gives us the option to keep the sampler that it used, because what it does is it sets up a temporary sampler and automatically places some control points around to generate a path. And in some cases it works out alright, but in most cases what you probably want to do is keep this sampler. And yeah, see, that didn't quite work out. So I'm just going to delete the fixture that created, and I'll select the sampler, and now we can see that there's a bunch of control points there that we didn't actually place. And we also now have the option to play with these sliders and get a much better solution than the one that we had with the default settings for max points and min angle. So somewhere like about that'll do. Okay, so that's another way you can do things. If you have something that is much more likely to work out, like for example this one, in this case I'd be pretty comfortable with doing a fully one-step solution here. So create body and fixture from image. I think we can just click through these. Keep sampler, I'll say no, and we should see here that we've been given a pretty reasonable fixture for that. And if we look at this in the player view, we'll see that there's a body created and there's the fixture obviously, and we've also had the image attached to the body as well, so they're all ready to go. So we can see here the image is attached to the body. I didn't quite finish this, did I? So let's select that body and select this sampler, and then we'll do create fixture from sampler. Okay, so now we have a fixture that actually looks quite reasonable, and we didn't have to go around and place all those points ourselves. For a lot of cases you may find yourself adjusting this result anyway, but hopefully it should take a lot of the tedious work of going around and placing all those points manually yourself, at least for the first pass. you can always polish it up a bit later. So that's how samplers work, and you can see what we're doing here. If I look at this image that we're using, this is another image for which we have removed the background alpha, so there's a transparent areas here, and this is quite an easy way of finding edges, because all we do is we just look in here and we try and find a place where we've gone from no alpha to some alpha, and we put a pixel here as our border point. That's how we've got these green points around the border like that. What we can also do with samplers is we can also use the color data in them, and let me just take this again. We'll use this again because it's quite a good one, and I'll create a sampler from image gain, and this time I will turn color edges on and refresh. Now we can see that as well as around the outside, we also have some green edges showing inside, and this is not a very good example of an image that you would want to use this for, but it should be apparent that what we're looking at here is the lines between areas of different color, like that. And they're not very strong in this one, but sometimes you can get images where they are a lot more defined. So let me just turn edge refreshing onto auto for this one, and we'll take this image. This one has a lot more clearly defined edges in the color there. So if I move the sampler onto this, we should see that we have some nice edges here that are a lot clearer, and we can use those to place our points along like that. So we're not actually using the alpha edges here, this is color edges now. And if the color edges are strong enough, we can do the same thing that we did before and get a fairly nicely generated I do that every time. What happens if I move this over here? Yeah. Put that up there. Alright, that's not quite what we want. Let's force it to go down there. Right. What was I saying? Yeah, so we can do basically the same thing here, except where we're not depending on having a pre-processed image with alpha edges nicely set out for us already. Put that one there. So as you can see, we've pulled out the color edges, and we now could make a physics shape from that pretty easily. In practice, I don't although I put a lot of time into making this system, I don't know that it's going to be anywhere near as useful as the normal system of just having alpha and non-alpha borders to find edges from, because in a lot of situations, like this is an example of where it's very useful. In a lot of game setups, like for example something like this, you can see in here the edges are not anywhere near as clearly defined as they were in that last image. So yeah, your results may vary. This situation's good, this situation's not. But at least it's there, and you can play around and experiment and try things out, and hopefully it'll take some of the work of creating larger level polygons like this out of your development cycle. So that was a bit of a long video, but hopefully it wasn't too boring, and like I said, I will make another video fairly soon explaining in more detail about how to set up these samplers and edit the paths in them. And I'll go through what all these settings are here and so on. So, thank you for watching.